All right, so we are going to go over the 6 views of a function. Before you can see the template that we use in class and the template that I use in our digital reference on our Google Slide assignments. This prompt gives us the rule to start, which is y equals 3/4 x minus 1, and we have to create the other 5 views given that one view. So the first thing I'm going to do is make my verbal model. I can see that y equals, so 3/4 x minus 1. So I'm going to start with 1 less than 3/4, and remember we have to write it in words. Fractions are hyphenated. 1 less than 3/4 of the domain. Remembering the word of implies multiplication in this case. 1 less than 3/4 of the domain is the range. Other ways you could have wrote your verbal model. The output is 3/4 of the input minus 1. You could use the words, the range is 3/4 of the domain or of the input minus 1. So there's many different options you could have for your verbal model, as long as the symbols and the operations in your rule match the verbal model and word choices you selected. Now I'm going to move from rule to table, and my first line or row in my table is going to be my header row. My first column is going to represent my domain values. My second column is going to represent the function machine calculating the output given the input. My third column here will be my output column, and my fourth column here will be my ordered pair, where I'm connecting the input with the output in a different display. So since my coefficient of my x is a fraction, I'm going to choose my numbers wisely. The first choice I have is an integer that is negative. So I'm going to choose -4. My second is not a choice, it will be 0. And my third is a choice of any positive integer I'd like, and I'm going to choose +4. The reason why I chose the -4 and the +4 is when I multiply these integers by my coefficient of 3/4, I get an integer as an output value. And that's what I'm looking to do. So I'm going to insert, or what we call substitute, the x value into the equation, and I am going to simplify for y. So 3/4 of -4, I'm going to set -4 up as an integer, as a fraction, where I can multiply. So I get -12 fourths minus 1. -12 fourths is also known as -3, and -3 minus 1 gives me an output of -4. So it just happens to be that this input matches its output. So now I'm going to put it as an ordered pair, since I know the ordered pair is going to show up as a location on my graph. Going back to my table, now I'm going to insert the 0 in for the x value inside my equation. I'm going to set it up. If you wanted to set that up as a fraction, I'm going to multiply that. I get 0 divided by 4 minus 1, which is 0 minus 1, which gives me an output of -1. Therefore, 0 as an input gives an output of -1. Now moving on to my positive value of 4. Substitute my 4, change it from integer to fraction, multiply my numerators, multiply my denominators. I still have that -1. So then I get 3 minus 1, which leads me to a 2. Ordered pair 4, 2. So I just finished my table where I chose a negative, used my 0, chose a positive integer value, substituted my input values, and simplified for my output values. Now I have to make the domain. The domain is given in set notation in numerical order. So I have a -4, a 0, a 4, and I'm going to put one more in the pattern, and the way that this X is counting, my next one would be 8. Close in set notation. My range, open set notation, needs to be in numerical order. I need that pattern point. -4 to a -1 is an increase of 3. -1 to a 2 is an increase of 3. So 2 increased by 3 would give me that 5. So I'm going to write that in numerical order. -4, -1, 2, and my pattern point of 5. My relation is my set of ordered pairs. So technically, it would be the last column in my table displayed horizontally. So I have -4, 4, ordered pair 0, -1, ordered pair 4, 2, and my last pattern point, ordered pair 8, 5. Since relation needs to be in set notation, I need to close that up with my braces. My one and final view left is my graph. I can take my ordered pairs from my table, or I could take my ordered pairs from my relation to graph the overall outcome. I'm going to go to -4, 4, 0, -1, 4, 2, and my last one happens to be off my grid. So I have 3 here. I'm going to take a straight edge. I'm going to connect those 3 points with a straight edge. I'm going to make sure that I have my arrows at the end, and I could even label this on my coordinate plane with the rule y equals 3/4 x minus 1. Now I've fully completed the 6 views of a function given my rule